I work with the Witmer group. It was kind to me, it says 40 years, but I actually have 50 years of masonry experience. I don't want to show my age, but in new construction and restoration work. I was involved with a very large company in the new masonry side where we did in upwards of $40 to $50 million worth of restoration and new masonry work, and now I'm strictly in the restoration end. I have a severe passion for masonry and masonry restoration work. And with that, I'll introduce our team. The first one here is Andy Barnes.
Hello, I'm Andy Barnes. I'm the Vice President of the Waterproofing and Coatings Department for the Witmer Group. I've been in the business for about 33 years now. We do masonry caulking, waterproofing, air vapor barriers, all types of sealant and coating work. Mike?
Good afternoon. My name is Mike Violet. I'm a senior project engineer with REI Engineers. We're headquartered in the North Carolina area. They're making me look a little younger than I am there. I have more than 35 years experience. I have over 40 years of experience. Most of my work is dealing with the built environment and buildings that have problems. I'm a professional engineer and a registered roof consultant.
What we would like from today's presentation, we'd love if the whole entire team that's here today would be able to implement effective strategies for your buildings and establish preventive maintenance. We would love if you were able to understand your building and know components, key components with your building, and understand failures that are happening with all the buildings. Also, we'd like you to be able to speak with knowledgeable and skilled craft people that you could understand whether they're the team for your job. And in the end, we would like you to be able to form a team that's going to be best adequate to support your needs. The first project that I'd like to talk about is a building in Lancaster City. It's a residential home. It's a historic home, and all our presentations will start with the call, and we all receive a call where we're asked to come out and take a look at a building. As soon as I came out and looked at the building, the first thing I saw was the building itself was about a 3-story high building, a brick veneer building, and the brick itself was bulged out in the center up around the 2nd floor level, and you can see probably in this slide right here, we put a line right here around this wood soffit and went to the top of the building, and the brick right here was pushed out about 4.5 inches. I knew there was a reason why it was pushed out like that, so I started looking at it in depth, and what happened was on the lower slide here, all of this area here was covered with wood cornice. So immediately I took the wood cornice off so I could investigate the area and see why the building was moving like it was and why they had so much deflection in the masonry. So as you can see here, there's a large wood beam that comes over and sits on this pier in the end of the building, and what happened was the rain gutter system was built internally that you can't see it from the ground, and all the wood was rotting, so water was running through that drainage system here down and into this main beam. So that main wood beam, we run into it a lot where they integrate wood into a masonry building, and they used to do that back in the day, but you don't see that anymore. You see where they're putting in large structural steel members to support your masonry. So as soon as I saw what was really happening with this facade, the very first thing we did was we came in and we put enclosures around it, and I put temporary shoring up on the building just to put it as a safety factor for the people and the residents in the area. So I immediately, once we started looking at the building more in depth, I realized we had to have a structural engineer come on board. So I got with the homeowner, they contacted a structural engineer, he came in and put a price together, and of course the owner thought that price was way too high. So the building sat for 4.5 months like it is right here, And email after email I sent to them and said that this is temporary shoring only, that they had to get an engineer on staff immediately. So what happened was they got a hometown discount. There was an engineer that lived about 3 doors down from this home. They got a hometown discount with an engineer, but he went radio silence on us, and I didn't hear anything from him for months. So I had a letter sent to the homeowner, and registered letter to him to just explain to him that the shoring was just temporary, and they were going to have material that was going to be on the sidewalk, that it was going to fail. So they enacted, and they started getting this engineer on board, and he generated a set of drawings. And then what we did was we ended up tearing down all the masonry. We started tearing down all the masonry, and this is what we found behind it. All the brick, everything was so badly deteriorated. So we ended up taking all the veneer down in that whole front of that building down to the ground. Down here in the bottom here, this was all replaced with a large structural steel beam that went full length of this house. And then we rebuilt all the masonry, all the brick from there up. So one thing to take away from this project is that you have to enact on it. You have to understand your building materials. When you have something so bad like this, you have to act on it right away and get it done for public safety and for yourself. But it was a good project. I'm glad it got done the way it did. We drive by it all the time in Lancaster City, and it looks beautiful. So with that, I'll turn it over to Andy, and Andy will go to the second project that we have.
This is a project that we received a call on. They were having it's an apartment complex, multi-units in 4 buildings. They were noticing like a mold, mildew smell inside of the building. They were having some water infiltration in the building, and they just decided we need to open an area up and see what's going on, because this was multiple locations. It had a brick wainscoting around the bottom of the building, so they tore all the brick wainscoting off, and it was vinyl siding with a building wrap on the exterior of the building. When they did the demo work, you can see what they found. Like in here, the wood sheathing was all rotted. There was P-TEC units right here. The sleeves were not draining properly. The moisture was going inside of the wall cavity, causing all kinds of damage. Even studs were rotted up above here that had to be replaced. And what happened is when they built the building, they didn't flash the windows properly. They didn't, detail around the perimeters of the openings. There was all kinds of issues here. So basically, what they did is we built a mock-up. They demoed a whole area, replaced any damaged sheathing, and then flashed everything properly. They flashed all of the windows. You can see here the P-TEC units were flashed. Flashing was put around all of the openings, and all of these apartments were occupied at the time that we were doing this too. They would pull a window in a P-TEC unit, it would get flashed around the window, and the P-TEC unit would go right back in it. And you can see the detailing around here, and then this is like the completed assembly of how it should have been sealed up originally when the building was built. And here is like the magnitude of this project. It was 4 different buildings. The one building here is that we're working on, and then there's several other buildings here. But this is just an example of something that they noticed, some smell, a little bit of moisture, and it turned out that there was severe structural damage and sheathing that needed to be replaced, and every building was taken, the whole veneer was taken off on the entire exterior, and a new air barrier installed.
The next project that we'd like to talk about, it's a large private university. This university, we do just a ton of work at the university. They probably have up to 25 or 26 masonry buildings. And this building here is identical. This entire feature that you see here, this entire elevation is duplicated on the north side of the building. I was asked to come in because they had a water leak issue. You come in through the offices and you come into this large facility, large auditorium. They have basketball games in there, graduation in there. And like I said, this is a duplicate elevation of the other end of the building. So I received the call about the water problem that they had. So I went directly above where the water leakage was into the building. And I opened up 3 or 4 different areas down at the base of the wall where you had a rising wall that went above a roof. And when I opened up 3 or 4 areas, I looked at the flashing installation, and the flashing installation was just horrendous. Now this building is only 13 years old. So, and I actually watched this building being built. We were doing a job only 3 or 4 buildings up from this one, so I saw a lot of this building as it was being built. But after I opened up the first area and saw the flashing and how horrific the flashing conditions were, I started opening up. I first went to the facility director and the president of the university, and I asked, can I do additional investigation areas, because I wasn't happy with what I saw. So I put a camera inside the wall and I opened up a couple areas, and what I found was this wall here, from about the base to the very top, it's 28 feet high. And when I opened up areas, I could look that full height of that 28-foot high wall, and there was no backup system whatsoever in it. It was just brick veneer on one side and 4-inch block on the inside of the auditorium. As soon as I saw that, I knew I had to hire an engineer, so I hired a very, very good engineer from our area, and I had him come out, and we did a really intense investigation of the whole entire area, including this section right here. So the other areas where they had the water leak, but we figured that both the construction methods were done the same identical way on both sides. But when I did hire the engineer and I brought him on staff, right away as we went back with our findings to the university, and it ended up going to litigations. So you can just imagine on both elevations, I don't have pictures of it here, but on both elevations we had scaffolding built on this side here, on both ends. On the back side of this wall we had scaffolding built, and it sat there for 6.5 months through winter while it was in litigation. Now the bad part of the litigation was I was involved in the interviewing with all the original contractors that built it. So I wasn't a very, very good guy to sit down in a meeting, because I knew what happened with the building. I knew the blatant disregard for construction codes and methods that was done in this building. So it ended up sitting, like I said, through the whole entire winter month, and then come spring, they worked all the details out financially. And then what we ended up doing was we tore down all the brick. We took all the brick on this elevation from here all the way up on both sides of the building. And it was even worse than even what I thought, because like right here on this side here, that's the brick veneer, and that goes from there 28 feet up with nothing tying that in. And what you'll see on this slide is some of the anchorage that they use for the veneer. You never ever want to see anything like this. Like right here, this stone that's right here, they have this stone. It was 2,800 pound stone that was tied back with regular tie wire and a Tapcon right there. So what you see here is a lifting hook, and that's what you set these panels with large cranes. This is what we ran into, and that's why the college was able to do all the work. It ended up being close to $1 million worth of work, and it was all because of them asking us to come in and just look at the water leakage problem that they had. But it was a major rebuild, because what we had to do in that 20-foot high sections of walls, we tore all the brick off and we built new backup walls. We put exterior dense glass on it, an air vapor barrier system, and then we put all the anchorage back in identical to what the codes require, both horizontally and vertically. And we do a ton of work there right now, but this was probably the worst job I ever saw in my life as far as constructability, and it was a very good contractor that originally built it. They just did not have their finger on the pulse, and all they worried about was getting the building up and getting it done according to the schedule. So. And Andy, I'll take this one. So the next one is what we run into. These are typical failures that we see in parking garage structures. What we see here is a lot of surface damage driving surfaces. Vehicles are on these decks all the time, just spalling concrete. Over here, it's hard to see, but we probably have maybe 20 or 30 areas here that we have concrete removed already right down to the structural steel. So once structural steel is exposed, you have to get all the way around the structural steel, remove all the concrete, coat all the structural steel, and then prime and put your repair materials in. That's prior to putting any coating system on it. The parking garage itself, these are surface damages that you see, but what happens with this, it turns into structural issues. So when you have surface areas that are so badly deteriorated, everything goes right through them. So you have to remember everything that's brought in from vehicles that park on parking garages. You have ice, you have chemicals, you have de-icing materials that come in with vehicles. And while that vehicle is sitting there, all the ice and everything comes off of those vehicles and onto the concrete surfaces. So it not only affects the top surface, but it comes down to your structural components. What you see here are large concrete haunches, and they're made right in a manufacturing plant. So when they make the walls, when they pour the vertical walls, they come in and set the walls, and then your large WTs, they'll come in and they'll set on these haunches. And you can see how badly deteriorated they are. It's just horrific. And it's not only on them, it's also on large structural components where you see large voids coming out. This is a large bearing beam, and it's just completely destroyed. And usually the problem is on parking garages, they only budget so much money yearly that they can take care of issues. They might put $40,000, $50,000 in a year, but it never catches up to the amount of deterioration on your garages. And a lot of it has to do with preventive maintenance that they can do. Like on all garages, the facility manager should do a walkthrough every year. He should do a walkthrough every year, put a list of any defects that they see on the garage. They should evaluate their snow removal process, because what happens, especially on the top deck, what they'll do is they'll move all the snow off the driving surface so the cars can park there, and then they stack all that snow, which has ice and chemicals on the perimeter of that parking garage all the way around. And then what happens is that saturates down through. But there's very few facilities that we run into. There's a few that do it, but very few of them come in the spring, and that's what really should happen. On every facility, parking garage facility, you should come in the spring and they should do a total wash from the very top deck all the way down to the bottom to get all the chemical components and everything off of it. Andy will talk briefly on the coatings part of it.
So yeah, along with the parking garages, like Roger mentioned, a lot of the things that you can do first before you get in some of those structural defects, you'll see coatings on the decks. Sometimes the coatings will be placed on the entire top deck. None of these pictures have it, but this is an area where the coating's starting to deteriorate here in a drive lane. These are, sometimes they'll coat just at the T-to-T joints where they come together in the decks. Other areas here, just spot areas. There may be a room underneath a certain part of the deck, like there may be a mechanical room or something underneath there that they put a protective coating on. Anytime you see any type of a bubble or anything, you need to get that repaired right away. Delaminated coatings. Some of these coatings here, they started out probably a little bubble. They were just left go way too long. They're starting to peel up, and the whole thing has to be removed at this point and replaced. Also, not only in parking garages, you may see some coatings on balconies or plaza decks on apartment buildings. They get a base coat of coating down. They get an aggregate broadcast into it, and then a top coat put on it. They can put striping and things on it. Here's another top deck of a garage where just certain areas were coated, and this was at a facility where there were just T-to-T joints. So you have to keep in mind, if you have any coatings or anything like this, they're not just a one and done deal. They have to be replaced, and there's maintenance required on them. Also in the garages, there's sealants. So all of the caulk joints, like this particular garage didn't have any coatings on it. This had a water repellent applied to the top of the deck, but over time, the sun, the UV deteriorates the sealants here at all, like between the T and the wash and the T to T joints. So they all have to be cut out and recalked. You see here sealant failures, and that just allows that water in, like Roger was saying, and causes damage and stuff to the structure if those aren't replaced. Another project that Roger will talk about, a restoration job.
Yeah, this project is a large brownstone church. It's in the Spring Grove area in Pennsylvania. It's a beautiful church, but the picture that you see right here on the left, this is what the church looked like originally, and this is what it looked like when we completed the project. But our whole entire project, it was well over $1 million, and it was all caused by that guy right there in the middle, or in the end. That was a piece of stone that fell off the top of the bell tower, and they had a volunteer staff that was out planting flowers in the spring, and there was a volunteer that was probably from me to where the slides are, that was planting flowers, and that stone left loose here and came down about 118 feet and landed right alongside of them. So I got the call. So I got a call and I went down and I looked at it right away, and I was up on every elevation that you could think of on that roof. I was up in both bell towers. I was everywhere you could possibly be on the church, and I looked at everything on that church, and there was so much deterioration. There was no work that was probably ever done on that church for 80 years. So you just can imagine what the amount of deterioration that happened on it. But you can see some of the areas of how bad the stone were. These are coping stone on the top of the building where you tie into all your roof structures. I went out and I did all the drawings myself on this job, and there was 374 different profiles of stone that I had to draw up for this church. So, I mean, it was an extensive project, and it was probably about 10 months long, but we worked with an excellent precast company that could match the brownstone in strength, in color, in texture, and all of it had like a serrated finish on all the pieces that we ended up putting back on the church. It was a beautiful job, but in all there was about a little over 3,000 pieces of precast that we replaced. The entire, you can see here the bell towers, both bell towers, this one, both of these here, were both rebuilt. We took down 9 feet on the lower one, and we ended up taking 16 feet off of this bell tower. The roofs were so deteriorated, all the wood beams and structures and rafters were so rotten that we had to tear all that masonry down, and then we rebuilt the roofs. We installed new roofing, and then we rebuilt all the masonry on the project. But you can see, when you pulled into town, it was the first thing you saw, this massive scaffold structure around this entire church. But I can say one of the things that was really critical, I had a salesman come out to me, and he tried to convince me that there was a material that you could use. It was a consolidant material that we could put on all this brownstone, that it would actually bring strength back to the brownstone. He said it was God's way of remaking a stone identically how he made it. So all stone is made under heat compression on the ground, and you bring that out, but over the years it wears out. So this consolidant material, I didn't have a real good feeling, so I thought, well, what I'm going to do is I ended up taking quite a few of these stone off of the top of the building, and I took identical pieces. I took 8 different pieces, and I cored all 8 pieces. So I tested 4 in this consolidant material and 4 without it, and I sent it to a lab to be tested. And all 4 pieces that came back to me came back probably 30 to 40% stronger than what the original cores were. So I'm sold on it. I try to push it all the time as far as this consolidant material on natural stone. that you can bring strength and integrity back to the stone. But
How's that applied?
you can spray apply it or you can roll apply it.
Okay.
Yep. And it's a beautiful church. And I think one of the things that really helped this whole entire project was we ended up putting a consolidant material on every piece of stone on this building, and we ended up putting water repellent over top of it. Both materials are very compatible, and I'm not a proponent of water repellents, but I think in the right application it does a great job. So anything you can put back onto the building that will give it longevity, I think that's really what we did with this. But I can truthfully say I can drive by this building today and it looks like it's identical to what we did 8 or 9 years ago. It's beautiful. I mean, it just looks like it was just built. So it was a great project, and we had such good stone masons on the job and repointing. But one of the really unique things is when I came out on that job one of the first days, all the way around the whole entire perimeter of that church, there was brown sand all the way around it. And it just looked like kids play sand going around that building. And what it was the face of all that stone that was coming off. Every time you get a driving rain, it would take more of that brown sand off the face of it. But it was all, this entire project, like I said, that stone right there is $1 million stone. So, and I'll turn it over to Andy, but one of the things that we talked about as a team, your building may not be able to talk, but it is saying something if you know what it's saying. So just look at your buildings, and I'll turn it over to Andy.
So we talked a little bit about the sealants on parking decks, but every building has some type of a sealant on it. There's all different types. There's silicones, there's urethanes, and they all deteriorate over time. So I just want to go over and show you something that you should be looking for on a building. The sealant is your first line of defense. So any open voids or anything is going to allow water into the building. So you just want to make sure that those are addressed. If you see cracked joints or anything, they should be taken care of. So different types of failed joints, you'll see them many different types. Here, masonry control joints, just a caulk joint running up through the block, wide open there, allowing a direct path for water to get into the building. You have precast panel joints or a tilt-up panel warehouse. The buildings are joined together with sealant. They build the precast panels or the tilt-up panels. The tilt-ups are built on site, precast are trucked in and then stood up, and then a caulk joint is between the panels to allow for movement. Those sealants will fail and deteriorate over time. Between different types of substrates, you have sealants. Like right here is an EIFS system where it meets a piece of precast and the sealant is all deteriorated and needs to be replaced. When you see it starting to chalk up like that, that's a good sign that that's a urethane sealant and the UV has just broken it down over time and it needs to be cut out and replaced. Another location that you see a lot of failures, window perimeters. The joints around the perimeter of the windows need to be recaulked, but also the glazing gaskets. The glazing gaskets over time will shrink up, separate, and leave a void for water to enter into the frame. With that, it's Mike's turn finally.
All right. So that leads us into the engineering side of things. I do want to say that I've had a wonderful privilege of working with both Roger and Andy and the Witmer team on some of these projects that are shown and on some of the others, and they really are diligent and make the engineering side of things a lot easier. So having and implementing a PM plan is important for mitigating costs and extending the life of your building. We opened this by saying it's a facade presentation, but as you can see, we've gotten into a lot of things. We've gotten into facades, we've gotten into parking garages, and I may from time to time jump into roofs. As I said, I'm a registered roof consultant. So, we can mitigate these costly damages by regular inspections You know, as Roger said, our buildings can speak to us, establishing a regular schedule, and then monitoring and documentation. All of these presentations that I go to and listen to seem to talk about sustainability and LEED. So I'm going to make my sustainable plug right here and say that I think one of the most sustainable things we can do is to preserve our built environment and make our buildings last a long and useful service life. We want to maximize that. So talking about a maintenance and repair program or a PM plan, you know, where do you start? You've been dealt a hand. You've got a building, and you need to know how to deal with it, how to maintain it, how to prolong that service life. So we need to know our systems, our buildings, and our structures. And we need to know what to do and where to prioritize things. So I'm going to speak a little bit about parking garages. We went through a boom 50 years ago when the demographics changed and we had a parking garage boom. We've got parking structures of all types. Older ones are built integral with the buildings, a lot of times below grade. Newer ones, we're seeing a lot of standalone structures, precast and post-tension and pre-stress are a lot of the predominant systems that we're seeing. And they're all unique. They all have unique aspects. They all go through volume and dimensional change. They're subjected to static and dynamic loads. We've got environmental issues with water, with chemicals, with de-icer salts, things like that. So we'll want to know what to look for in these structures. These ones that are cast in place, maybe one-way or two-way slabs, you know, we'll get some cracking. Concrete's going to crack. We certainly want to minimize that, but we want to know what that cracking means. So educating ourselves about the type of structure that we have is important. And walls are the same way. We've got a lot of different wall types. Our older ones, whoops, hitting the wrong buttons here. Yeah. So our older buildings are a lot of mass masonry construction, and they rely on storage. You know, the walls get wet, the water starts trying to migrate into the building, but the thickness of the system allows it to be stored and then allows it to dry to the exterior. You know, we also have water managed systems, drained type systems, and although this may also be you could call it a barrier, we have barrier wall systems. So we need to understand those. And then we also have managed wall systems with a lot of different veneer materials on them. You could have a masonry veneer. You could have metal panel open joint rain screen systems. You could have lap siding. We could have the exterior insulation finish systems on them. So we kind of need to educate ourselves about what we're going to be looking for. Water's powerful. Roger had a good example there, and I think we've all heard where water will turn mountains into sand, and you know, Roger had a good project experience with that. So we want to manage the water. It's like a cancer. You know, if we allow it to build up, to lay on our parking decks and penetrate, to build up into our wall systems, we're going to see problems with corrosion, mildew, interior environmental problems, you know, the M word that we don't like to say too much in public. So the water managed systems, they rely on integral flashings, weather barriers on the backup walls, weep holes to allow the water to discharge out of the wall system. And usually you'll find those wherever there's a horizontal interruption in our wall system. It could be a deck. It could be angles for window heads, you know, supports at openings for window heads where you'll have a flashing there. It could be at the base of the building. So there's a number of locations, and this picture, you know, has a good example. Balconies, windows, terraces, roofs, doors, all of these things are interrupting our wall system, and that is where you're going to find your flashing, your water managed system within the wall. So we need to educate ourselves about these things. Oh, there we go, sorry. So maintenance mistakes can also lead to problems with the building. One of the biggest mistakes we can make is probably turning somebody loose, a handyman with a caulk gun, and say, hey, there's holes on the outside of the building, I got water coming in, can you get out there and take care of things? And then you'll see things like this happening, where you've got a weep hole in a flashing system above a window that somebody's gone out and caulked because water, I've got water coming in, they see a hole, first thing we're going to do, let's caulk that up. It must be getting in through that hole. So really getting a good understanding of your systems, your parking structures, your building in general is going to help you in preparing your preventive maintenance plans. This is a picture. I didn't actually work on this building. I was driving down the road in Reston, Virginia during the wintertime, and I see this, and it made me want to stop and go and say to these guys, hey, you guys have a problem up on your roof. You got a 4-story icicle hanging out through an overflow scupper. So your building may not talk to you, but it can be telling you things, and that's probably one of the first things that you really want to do is a thorough visual assessment of your buildings. We've got a lot of different materials on the exteriors of buildings and parking garages and any structure that work differently. You could have unaccommodated movement between masonry and steel elements in the building. I love this picture here. It would have been just a straight veneer run up the building, and then all of a sudden you've got some bulging and cracking occurring. Well, if we looked at our drawings and saw that, hey, there's shelf angles at every floor, and we should have a joint, beneath that shelf angle. You look here, you don't have one. Well, that masonry is always expanding. Okay, so as it expands against a steel angle that's below here, it's going to start bulging out, and then at some point, it's going to be developing these cracks. So it is telling you some things with your building that we need to pay attention to. When we get a lot of efflorescence on the outside of masonry walls, we're getting a lot of excess moisture going through our building and carrying the salts from the mortars out and staining the surface. So again, it's the kind of way that your building is speaking to you. So we'll get into a little bit of assessment. There's lots of tools that we have in our tool bags. Even Roger mentioned his tool bag. He's got a pretty big one. Borescopes for getting in and looking at what's going on inside the building. We've got non-destructive testing methods, utilizing infrared, capacitance, all kinds of ways to test for holes in membranes, for air and water infiltration through roofs and facades. If you get into building commissioning and things like that, we've got pressurized testing of rooms for air infiltration. I use that a lot of times in conjunction with water testing to create a pressure. Because a lot of times somebody will say, well, I got a leak, but I really don't see it unless it's a really driving rain or there's wind. So we're creating the pressure with these blower doors or creating a chamber on the inside sometimes with some vacuums and creating a negative pressure so that we can produce that leak. And then we'll open the building up and see what's going on. And a lot of times that is the only way that you're going to find what truly is your problem as far as details go. Materials and detailing, and I did not hear Roger talk about that experience with his consolidant before, but that's a great thing. We're always looking for new and improved materials. Of course, we don't want to be a guinea pig a lot of times either with the new material, so the approach that Roger took to actually test it, to get his own confidence that the material works is great. If we've got cracks in a building, yeah, a penetrating sealer is not going to do anything. We need something that's going to be flexible and bridge cracks, whether it's in parking garages, balcony decks, could be on walls that have the exterior insulation finish systems, the EIFS systems on them. And then we want to make sure that we got proper details. I mean, we're still seeing these days a lot of water managed systems with flashings that are incorrectly installed. no end dams, flashings that don't come out beyond the face of the building, improper weeps, steps in flashing. So these are things that, we look for in detail so that we can make sure the water is properly managed. So that kind of brings us to some cost implications that we need to be aware of. Our buildings are getting really complicated these days, the way they're being constructed. And that makes sometimes these assessments pretty costly, just getting access to the buildings. This is why we're looking at utilizing things like drone technology, where we can fly around, get great images, and utilize those without having to bring out man lifts, build scaffolds, just to get access to do what we need to do as far as an assessment to come up with repairs. We've got testing that we may need to do on the building. All of this stuff adds to our costs. And then you start talking about the repairs. Again, access to the work area. This is actually one that we recently completed in Harrisburg with the Witmer group. A historic church, again, had some of the same brownstone issues that Roger pointed out on another church. So we utilized some of those improved products. Some of that brownstone was so bad that, in fact, we cast replacement pieces to match it, but used precast elements. These tended to be, way up here, so these are not things that are, well, you look at it, you wouldn't tell the difference just about, but a lot of the ones that we did replace were way up on the bell tower where they were extremely weathered. So we went with a precast material, so we didn't have that flaking and delamination of the brownstone at that high level. And then, of course, we did some supplemental anchoring and pinning to these things as well. This one may look familiar. This is the one that Andy was talking about, the multi-unit residential apartment buildings. And this was the actual mock-up that we did. There's a spray rack there that we're doing some testing. There's a chamber set up on the inside, so we're recreating this wind-driven rain. And we thought we had all the details for this, really great. And as far as the window and the walls and things like that, it worked great. But when we were inside, we're seeing all this water come in. And it was coming in through this PTAC unit that Andy referenced earlier. And we realized we had all kinds of issues with the pan, with the drainage of this pan, and the water was getting through the PTAC unit into this pan and just kind of sitting there or working through joints in the pan itself. So then not only were we redetailing windows and walls, but we're having to detail the condensation and drip pans that are in there just so that we don't have a big problem there as well. I mentioned roofing. Well, this is one of my pet peeves right here. Pitch pans in roofing. So I thought this was a good way to show if you can minimize preventive maintenance by improving details, I am all for it, okay? And this was a good example that I could come up with to show that, where instead of having this metal pan through a roof that is filled with goop that you have to replace every few years, that you come up with a nice stainless steel detail that you walk away from, and your PM guy really doesn't have to worry about that. These, when you do roof evaluations, anytime you see one of these, it's a hole. You put that down as a hole in the roof, basically. And it's a maintenance issue and a maintenance nightmare. So wherever we can get improved materials, some of which Roger alluded to and Andy alluded to with sealants, or improved details or correct details, we want to do that to help us in our preventive maintenance plan. And then another big cost implication is consequential damages and what happens inside our building. The gymnasium that Roger mentioned was great. They had to find completely new venue for graduations and sporting events and things like this. A lot of times we'll have to move people from inside, furniture, equipment. There's a lot of consequential costs to water infiltration into the buildings. And then some other things that we have to do with like parking structures, where not only when you're working on a parking structure, do you have to shore directly under where you're working? A lot of times you have to shore multiple levels. So you think, okay, I got to do shoring. I'm taking out a parking space. Well, no, you're taking out parking spaces on several levels. You may be changing how the flow is in the garage. There's a lot of implications there. Dust protection. I'm working on a building right now with a cooling tower inside a mechanical unit or a mechanical room supported on column posts, and we're going to lift and repair the columns and replace the dunnage that's all corroded. And there's an operating mechanical room here with other cooling towers, with other equipment that we've got to keep dust contained and then collected. So that's going to be a big cost that the owner probably wasn't thinking about when we got into it. But it's those kind of things. And then the one thing that Roger did mention in the one case, litigation. A lot of the things that we look at, you know, somebody wants to blame somebody. So there's a lot of litigation costs related to water infiltration and the deterioration that happens with that infiltration. So, effective maintenance strategies, that's what we want to come up with. We want to be proactive. Okay, we want to be planning our maintenance and repairs instead of reacting to emergencies. And I think the presentation that follows this might have a lot about some of those emergencies that you see specifically in parking garages. You know, we can't control a lot of things. We can't control design. We can't control material choices. We can't control construction. When we're given a building to manage, we can't control those things. But we can control the PM side of it, you know, and we can plan for repairs. There's great strategies as far as coming up with checklists. I'm a big checklist person. I know for parking garages, the American Concrete Institute has some great checklists for you to just walk through your garage and check sealant joints, drainage. You know, are there cracks? Where are they occurring? Same thing with walls. Once you go through looking at, you know, your building drawings, maybe your warranty documents, that sort of stuff, you can kind of create your own checklists there too. And you know where you're spending time and money on these things, so they may be areas for you to prioritize and focus on. And we got a couple of shock and awe pictures here just to end with. These are not necessarily projects that we were involved with, but these are some things that can occur when you defer maintenance and are not proactive in your preventive maintenance plans. This is, you know, several collapses that we've seen here where building materials are falling right down on the street, right at entrances, and of course the one that we all have heard about and known about recently, the big collapse in Florida that seems to be changing, you know, regulations and rules with condo industries and how you look at your buildings and establish your contingencies and things like that. And we're going to end here with contractor selection. It's an important thing, and it really starts on the engineering side and the assessment and coming up with a detailed scope of work that can be bid by multiple contractors without ending up with extreme cost variations. You want them to be fairly tight. A lot of that will depend on the experience the contractors have. You want to have contractors with experience on the type of projects you're working with. Their reference and qualifications are important. I'm finding a lot of time, these days, a lot of contractors are acting like GCs, and they're just hiring whatever labor there is around, and you don't have a lot of control that way. But there are firms, and I won't mention any names, that have great training programs. They retain their people. They're all about quality construction, and those are important things in the vetting process of contractors to look for. And then finally, strong communication skills, a good team approach. We're all in this, you know, as a team, the engineers, the owner, the contractors, and so we all want to end up looking good. We want to communicate well and give a quality project to the owners. And I think that wraps it up for us. Thank you very much. Questions?